Here I am.
Hello, everyone. Welcome to ITS 140. Can you guys hear me?
Yep.
Great. Yes. Okay, so let's talk a little bit about this week, last week. So, believe it or not, we are currently on week 3. So that is incredible how fast things move. So we are on week 3, just starting week 3 right now. So that, we've completed 2 weeks. And at this point, you've had an opportunity to start working on your first homework assignment, which is due this Thursday by 10 p.m. Make sure you're working on that. On Thursday, during lab, we can go over the homework. So I will, kind of like what I did last week, I will just do a couple of problems from the new homework, but then leave it open for any questions you might have regarding the homework. Either one. Okay. So today, as you might see, we are going over. I'm using 2 books this semester. Because we're making this transition to have more Python in this class. So I'm still using the old book just to make sure I cover all the topics and tie it well, and the new book. So today I will be doing that again. Start with one set of slides and then move to the next set of slides. This class is pretty good because it's very structured. It's got all the material, all the slides. Pretty good. The slides are pretty good actually. Very detailed. So that's one thing. I've posted. So I hopefully you saw that I posted on the homework assignments. What I did is what I had said I would do. I will always just scan some problems. It may not always be from the book. I may just have problems of my, that I want you guys to work on, especially as you start getting further ahead in programming. I'll start probably throwing in some new ones in there from other places. But for now, I've scanned the first few chapter, some of the problem. And then that's what I'm kind of posting. That's what we're doing in the class. Now, in the book, the 2 books have a specific order in which they go. So it goes like they're both on same chapter 1 and 2. Then they kind of deviate, and so the next set of topics is decision structures, iterative structures, and modules and functions. And so I'm going to start with if statements today, which is decision structures, Boolean logic, even though it's chapter 4. So you might see that I'm skipping chapter 3, but it's only because chapter 3 is modules and it ties to functions, because Python mainly has functions and or the idea of a function. And so I'm kind of I will do those 2 together at some point, and sometimes I might actually do chapters in parallel. We'll see. But today, I'm going to do decision structures, Boolean logic. So the two most basic constructs of programming are decision structures and iterative structures. Some of you may know them as if statements, the if statement, that part of programming, and the loops, or the for loops, that other part of programming. So chapter 5 is for loops, iterative structures, for loops included. And so we'll do that. I mean, these chapters are big and important, so they might take a while to get through. Okay. But I can't stress how important they are. So programming, and what's great about programming is one of the great things about it is that it's not like other topics where you really build a lot of background and then finally get to the main course of the whole thing. Here, actually, we get to it pretty quickly. So, pay attention to this part. This is really practice. A lot of these. Remember, it's all about practice, right? It's all about practice, little by little. We'll get it. All right. So, so we're gonna get started with decision structures first. Are there any questions? Can you guys see the slides first of all?
I see them.
Great. Are there any questions before I continue? Okay, it seems there's no questions. All right, so as I said, decision structures, this idea is the idea of how do you, in a program, how does information flow? So you have to think of, we do these flow charts, right? And so now we might come to a branch point, right? And so you want to decide, do I go in that direction or do I go in that direction and execute this sequence of commands or this sequence of statements, right? So that's really, you have to make that, that assumption there. And so we you do that a lot in programming. And it's very important actually. And so we need to explore this concept, okay, in a lot of detail. There are, based on the programming language, there's going to be different ways of creating decision structures. Okay, so we'll see that. So we'll introduce, alternative decision structures when they're dual, like binary, maybe we're also going to do decision structures that are nested, which are, very important. We're also going to look at the case structure. All right, programming languages have this. And then, logical operators. So obviously it's all about, a little bit of logic there, your Boolean tables and things like that. The operators and Boolean variables. Okay, so, variables that are basically just true or false. And then, some of it is comparing strings. So one thing, whenever you're writing programs, you're always manipulating strings. That's really an important thing. Python is really great at dealing with strings. So that's one thing, one great power of the Python language. Okay, so just a simple definition. Decision structure allows a program to perform actions only under certain conditions. Okay, and this is going, at pretty much every program will always have some kind of an if statement, right? So not every program, but I mean functions that just do calculations won't. But in general, though, that's that's decision, right? So it looks at information. Now the information may be coming from variables. It could be coming from inputs from the hardware, files. I mean, many sources. Okay, different types of decisions include if also, called the single alternative, if then else, also called the dual alternative, and the case structure for multiple alternative decisions. So we will see these. Don't memorize any of this, especially in the age that you guys live. You will always, it used to be that 10 years ago, people would say, don't find code online and use it. Today, that's still the same. Don't find code online and use it. And just use it. Instead, you kind of want to write your code from scratch. And that's true. Certainly, you should always do that. But at the same time, you can always look for things online like you do in your book, right? And then understand what what's going on and then implement it yourself from scratch. So it's really important. So definitely don't memorize things. I do recommend that you just, practice. You'll get used to. That's why you have the problems to kind of work through things. And what the great thing about this is that, this is not like when you do like math and you don't know the answer, right? You just do the math homework and you think you got it right. With programming, you always can run your code, right? And you know what the problem is asking for, and then you'll know if you get the right answer. So it's very important, it's very satisfying in that way. And so, just, practice is the key. So introduction to decision structures, you can see here, our very first one is, the if statement. Okay, so, and that's, in Python, you have that, the if statement. So it's basically an action only occurs if the decision is true. Okay, so whatever condition you have in there, imagine that condition is in an island somewhere, right? It's in a deserted island somewhere. And that condition, regardless of how complicated, whatever is in between there, those two parentheses, that gets processed, and then at the end, whatever comes out, that's going to be either a true or a false. Doesn't matter how complex, it's going to evaluate into a single Boolean. And then that's where you decide what to do. So you do if true, then perform however many statements you want to have in here. And it can be many. And then sometimes, as you can see, this is pseudocode. Okay, so this is pseudocode. And so whenever in the homework it says to write the pseudocode, or in the exam, just in general, you'll have to write it like this. What this implies when you say if condition, then when you say if, then, and if, those are the reserved words in pseudocode for an if statement structure. Just be aware that that's not syntax. In every programming language will be different. Okay, every programming language will be different. Some programming languages like VB.net, VB, which is Visual Basic, for instance, looks like this, right? So I used to teach a very similar class to this many years ago, and I would do this in VB. And that's fine, it was like that. But, then you do C, and it's going to be more like if, and then it's going to have curly brackets, and your statements are in there. So the idea of a then and the idea of an indif was just these curly brackets. Probably draw this a little bit. Right, so the curly bracket on your keyboard. And that's, in C, C++. And then there's in Python, obviously, which is the language that we're using this semester. You do if, you have your condition there, right? And then all you have to add, instead of a then, is you add a colon. So instead of then, you add colon. And instead of an end if, there's no such thing as curly brackets in Python. Instead, you write your statements here. And what you have here, I'm just going to draw it like that. What you have there is indentation. That is to say, you add spaces so that there's a indentation there. Okay? So usually that indentation can be the tab key. Tab is about 4 spaces. Or it could be actual spaces. Some people do 2, others do 4. I like to do 4 just because if I do 2, it almost looks like that. And so when you're reading this, it's difficult to see, okay, did I get the indentation right? So that's why I make the indentation a little bit more pronounced by using 4 spaces. Some people use tabs. The one thing is don't mix them. Don't use sometimes tab and other times spaces. That's just, it may not, your code may run if you do both things right, but eventually, because tabs and spaces are invisible basically, you won't see that you have a tab here and 3 spaces over there, and it'll be hard to debug. And so definitely, you know, like you'll see me do 4 spaces, right? So as soon as you know, probably this Thursday, I will probably do at least 1 if statement, I assume, depending on how far we get. And that's going to be that. But that's in the actual Python syntax. If you're just doing pseudocode, then it's going to look like this, right? So it's going to look, you're going to have to write it like that just because we want to get into the habit of practicing. So as you can see, you know, this semester, this class, even though, you know, I'm introducing Python, you can see it's always the pseudocode and the flowchart that's where I'm putting the emphasis. And then I'm just showing you how Python works. I don't expect you guys to, I feel that you'll get a lot more out of it by seeing the contrast. And so I think you'll pick it up. All right, so now that's the pseudocode. Then we start talking about the flowchart, of course. We start talking about the flowchart, and as you can see here, for the flowchart, we're going to use a diamond symbol. So we use a diamond symbol in the flowchart. And you can see, of course, that's here. So as you start writing your solving problems, you know, you will have to then use these flowcharts, and that will be just like last week we learned about parallelograms, rectangles, and so on. Now you're going to be learning about you know, learning about this new symbol. Okay, so you know, the structure, as you can see, it's going to be a true or false. Now in this condition, this if only has one direction, and that's true because there's only if true, then and if. There's nothing else, right? So that one didn't have it, but we're going to see other examples where we have the false condition as well. That would be the other alternative. And as you can see, if true, the data will flow through this and only through that. It's going to tell you to do some activity, all right? And then it just continues to pick up where the flow would go, which is that way. If it's false, it goes in that direction, right? So it's basically flowing through like a circuit to achieve some kind of a goal. All right, so that's a simple decision structure, you know, on an everyday task, and the diamond symbol is used in the flowchart. Any questions so far? No? Give me a second here. All right, so the next part here is as we introduce decision structures, we're going to look at the relational, we're going to look at the relational operators. All right, so the operators are, you know, equal, less than, or greater than, less than, you know, greater than or equal, not equal. right? So again, this is the pseudocode, and sometimes the pseudocode translates to the actual syntax. Other times it's a little bit different depending on programming language. But basically, it determines whether a specific relationship exists between two values. So usually, as you can see, there's going to be two variables, x and y, and you're going to compare them. Right? So this is used within the condition, and it's called a Boolean expression. Right? So here we have some definitions of the relationships. So their meaning, as I said, the operator greater than, less than, greater than or equal to, less than or equal to. Notice there's two equal signs. And that's because usually when as we saw last week, if I have B plus C and I'm going to assign it to A, usually the symbol is just one equal, right? So it makes sense then that two equals are or equal to, right? And then the opposite of that is the exclamation and the equal sign, which means not equal to, okay? So that's the basic idea there. So obviously, knowing that the symbols is pretty simple. Once you start thinking about the logic, you'll have to do more exercises, especially as you start to combine these with other operators. So for instance, if you do x greater than y and some other thing, some other whatever relationship, but you can combine them there to produce even more complex logic, right? So that's a lot of the power of what you're doing is going to be expressed in these Boolean expressions, okay? The dual alternative decision structure, this is when you have, now the flow, right? Two paths to follow. So the dual alternative decision structure, if then else statement. Okay, so if then, and then notice the keyword here is else. So you have an if then else statement. It executes one group of statements if its Boolean expression is true, or another group if its Boolean expression is false. A dual alternative decision structure. So the best way to see this one is in this flow chart here. You can see the flow, regardless of how complex or simple the program is, it comes from there. Then you have, some kind of condition. In this case, you have a variable, temperature, and you're just comparing it. Is temperature less than 40? Right, so it's warmer or colder. So if it's warmer than 40, or if it's less than 40, so this is a little odd because we're used to things less than being to the left, greater than being to the right. But don't pay attention to that. Instead, just think of if temperature less than 40. Well, how do you measure that? Let's just have a value, 78. That's a nice warm weather there. And so 78, right? So if is 78 less than 40? What do you guys think? So you know this, right? So is 78 less than 40? What is that? True or false?
False.
Huh?
False. False.
False, right? False. So it evaluates to false, and then therefore you're going to go in that direction, right? So you're going to execute that. If it were true, 30, for instance, less than 40, true, then it would go in this direction. And it only goes in one direction, so it's one or the other, right? And then once it does that, then, here you have, either perform this print statement or display statement, or that one, okay? And then notice that once you do that, you exit the if statement and you just continue with the flow of the program as it was intended. Okay, so that's, you know, one of the critical parts there. Right, so you're just going to continue with its intended direction. All right, so now we have, so dual alternative decision structures, right? So we can see that here in pseudocode. So we have if condition, then perform these statements, else, right? So that's, you know, similar. So that's this idea here, right? So true, false, we did that. So now we express that if true, go in that direction, else go in that direction. So here is that, you know, equivalent diamond where you go either in one direction, so that direction, or this direction here, okay? So to see an example of this would be to look at the previous temperature idea. And so we have if temperature less than 40, then, and then we can have as much complexity as we want in there, okay? So we can have, you know, two statements, one statement, a lot of things. All right, and then we have the else statement, and then we just execute another set of statements as well. You can see these here. And then finally, as you know, just be aware that when you have structures like this, you always have to, every programming language will require you to open and close them in some way. Sometimes it seems like you're not doing that, but you are. You know, when you do indentation, for instance, in Python, you know, you do if, you know, and then indentation. Well, the moment that you write a line out of the indentation, out of this indentation, but align with this indentation, that's the equivalent of the end, right? So that's how you have structured that in a language like Python. As I said, in other languages like VB, C, C++, you do have a more of a symbol for ended, okay? So that, you know, that's probably one of the hardest things to, I mean, Python has very easy syntax, but certainly indentation might be something you have to get used to. All right, so that's dual alternative decision structures. Here we have, so are there any questions so far?
No.
Pretty easy, okay, all right. Feel free to ask questions though. You know, I know there's different levels of programming, so if you feel you want to ask something, go ahead. Comparing strings, you know, it's an intuitive thing for us to do, right? You know, and as I said, you know, Python is in C. This takes a little bit of work. Python is super easy to do it really quickly. We'll probably do this on Thursday, something like this. But let's take a look at it today, just in the pseudocode. Most languages will allow you to compare strings. Compare strings will be very important because, you know, you're going to be reading information from logs. People will enter data from, you know, imagine you're in your website, right? You're building a website and people enter their username and password. I mean, that's something that you do every day, right? You log into your Facebook or you log into your, you know, Brightspace, you log into your, you know, lots of things, right? And so every time you log in, basically you type in your username and password, maybe your email. And so that's a string, right? That's a string that you're always going to have to process. And you can see here that the classic example of comparing strings is actually a password, right? So evaluating a password. So, and you'll learn, you know, in this class, we're not going to learn about how to properly create code that processes a password. You know, that's something that you will learn in other classes because it's more of a, it has to be done securely, and there's a lot involved in that. But just here, we're just comparing a string with this example. So as you can see, you know, you have, what are these called again? These in pseudocode, these 2 forward slashes. What do they mean?
Single line comment.
Single line comment, right? It's just a comment, exactly. Very good. And so here we can see that we have the comments, and you know, first of all, you have some kind of a variable to store the password. You know, in the pseudocode, remember, declare string password. Yeah, so in here, although in Python we don't have to declare a data type, in other programming languages we may need to. So you know, declare string password. Then we have a prompt to tell the user to enter the password. So display enter the password, and then we have input, right, to the variable password itself. And then after here, we're going to perform now our new idea. You know, usually I'll just, you know, instead of writing the whole decision structure, which is kind of long, you know, so usually I'll shorthand, I'll refer to this as just if. And so here we have our if statement, determine whether the correct password was entered. And so you can see that the elements of this are basically an if statement, the variable password, the symbol that we're using, the operator to compare. So we have the equal sign, and then we have some kind of a string, Prospero in this case, you know, some word for your password. What is this called when you write it in the code? Just something in double quotes like that?
String literal.
Exactly, very good. That's called a string literal. Don't forget that. This was a perfect example to show you what that is. All right, and then in the pseudocode, then, right? And then over here now, we have our statement, right? So we have a statement. We just display a message, password accepted. Obviously, creating a password would not be a password program would not be this simple. This is very insecure. And then so we do if that direction, else. Notice over there that just means, okay, if this was not true. So if, let's say you wrote in the password, you wrote the word Purdue, right? And so Purdue equal Prospero, no. So then that's false. And that means then you go and you follow the path of the else, and that takes you there. Displays, you know, sorry, that is not the correct password. And then notice at the end of it, you know, you still always want to have the end if. And as I said, most languages will have different things. VB actually literally uses end if, I think, if I remember correctly. C#, C uses curly brackets. Python uses something. It's just sort of an invisible thing. And again, I'll repeat. In Python, if, blah, blah, blah. When you add the next line, which is no longer indented with this, but it's indented with that, that transition there basically is equivalent to the end, right? So just sort of think about that for a second. Okay, and now we see here basically the console program output, the input showed in bold. You're going to see that enter a password. So you entered Ferdinand, and then, you know, it's incorrect. You enter Prospero, and then it is accepted. So I recommend, you know, try this, right? You know, fire up your Jupyter Notebook or your favorite Python editor and just try to implement this. So a lot of the time you know, we do examples in the class, just implement them in your code, and just, you know, practice as much as possible. Any questions so far? Any questions about this? All right, no questions. Let's keep going then. So comparing strings, so, you know, to me, strings are a huge thing in programming. I really like, you know, dealing with text, you know, usually strings, they're referred to as text. And so, you know, it's a lot of fun. All right, so and I think we have a chapter later on where we will do a little bit more. Once we get through arrays, we'll play a little bit with strings, see the things that we can do. You know, if you think, I just want to stress, for instance, the fact that you hear of, you know, how Facebook is reading your messages, and Google, and obviously when you guys search, right, you do a search on a search engine, what are you typing? You're not typing equations and math formulas, right? You're typing text. And so all programming languages have to deal with text very efficiently. So there's quite a huge use for this. So you know, you'll certainly see a lot of this as you progress in your classes. All right, so other string concerns, string and strings can be compared, right? String and string literals can be compared. So like the previous example. So here we have, you know, we compare a variable to a string. Here we compare two variables. So that's, you know, an example of this, going back to the password, is when you type your password and then it says confirm your password, right? So both are in variables now, and so you can go ahead and just compare them, okay? String comparisons are generally case sensitive, and that's true. Case sensitive means that, you know, case sensitive here means that cat and cat, notice the uppercase over here, lowercase here. So these two are, if you do this, cat and cat equal, this is going to return false, right? Because they're not equal. Remember that in the ASCII table, these will have different numbers for lowercase c versus an uppercase c. You can also determine whether one string is greater than or less than another string. And that's because at the end of the day, they are numbers, right? So you can think of these letters as just the equivalent numbers. And so you can do those kinds of operations as well. Although that's certainly not done so much, but you know, you can do it for some applications, sure. Okay. All right, so now it gets a little bit more complex. Certainly, your flow charts, I think your flow charts will actually get a lot busier than your pseudocode. The pseudocode or the Python code are made to be written efficiently, kind of linearly, but you know, certainly creating the flow chart, it's going to get a little bit busier now. Because of this. Oh, by the way, talking about flowcharts and everything, I spoke with my department head and our tech rep, and I was told that you guys do indeed have Word. Okay, so all of you have Office. If you go to the course, so remember we had that discussion last week about you guys not having Office and having to go through some kind of a VPN or something. So that actually turns out that you do have Office. If you go to Bright, so what I did is go to Brightspace, and then in Brightspace, where I have the link to the course website, you know, where I have the calendar and all the links to the videos, somewhere in there under useful or tools or something like that, I added a link, okay? And the link just says you know, get Office. And so what you have to do, my understanding is you click on that, you're going to go to a website, and then you're going to need to log in. So apparently you can try logging in with your, you know, let's say your name is Mary Smith, so msmith@pnw.edu or msmith@purdue.edu, right? So try either one of the two email addresses, and I believe once you do that, you will be able to get access to Office. So you do have it. So that was confirmed to me by my department. You know, I should say your department, because you guys pay for this. And talk to, and if you have problems with getting the software, talk to Donna Alt. All right. So they basically told me, you know, just send her an email, just look her up, and the email Donna Alt. But they were the ones that told me that you do have Office. So you can use Google Docs. I mean, I'm not saying you have to use Office, by no means. Just remember that I have to be able to read your reports, and I use a Windows operating system for homework, and for homework, you know, grading. And so if you're using some other software, I'm not going to grade anything where I have to go online and like Google Doc it. I'm not going to do that, because, you know, I don't like to log into systems that I'm not familiar with, or that I, you know, for security stuff for your own grades. So it's got to be either a Word document that I can open on Windows, or if you created it on a Mac or some other device with some other editor, make sure you convert it to PDF, so that I will open the PDF on the computer. All right, guys. So just that. Don't send me a link. Don't send me things in the cloud or Dropbox. You know, it definitely has to be either a Word doc, or, like I said, if you use another editor, just make sure they all have this, convert it to PDF, so I can take a look at it. But so I was pretty happy to hear that you guys do have Word, in fact, and Office, I think. So that you should have the whole Office suite. Make sense? Questions about that? Comments? No? You're all quiet. Are you still there? Did you fall asleep?
Well, I'm awake.
All right, good. I'm glad. All right, so just I wanted to tell you that, because I know we had said that we probably don't, that we didn't have that last week. All right, great. All right, so yeah, so remember, as you start doing your flow charts, you can you know, do them in Word. There's something called Raptor. It's a program. You might, you know, there's a lot of tools out there, but there's a tool out there called Raptor. If you would like to learn how to run flow charts and see the data flowing a little bit more, like a little bit more interactive, you know, it's not required for the class, but it's certainly something you can try if you'd like, for those of you that really enjoy trying new things. All right, so anyway, so let's talk a little bit about nested decision structures now. So these will be a little bit more complex. We'll certainly do, you know, at least one example of this in the lab on Thursday. But it's basically when you have more complexity in your decisions. So you can see that in the flow chart here, we actually have, excuse me, we actually have two decision points. And let's call it decision points, right? So we have two places where we evaluate Boolean expressions to figure out if it's true or false, right? So here, true or false, here, true or false. All right, so now we have two nested, and it's called nested because this one is part of the previous one. And in fact, it only gets executed if this decision structure is true. If it's not true, then notice you're just going to go like that, and you never go into that direction, basically. All right. So decisions are nested in order to test more than one condition. So decisions are nested in order to test more than one condition. If, then, if, else examples. So we'll see how that works when we look at the pseudocode. But we can see here that let's kind of flow through this. And flowcharts are actually, you know, even though we don't use them, they're actually quite right. You know, flowcharts or programs are basically a whole bunch of places in memory and operations. That's, you know, that's basically all it is. And so you have data in those places in memory, and then that data flows from point to point. You're moving the data around your computer from place to place, and sometimes, you know, data, you know, two pieces of data come together and some operation needs to be performed. You know, it's usually something that the computer can do well, efficiently. And then after that, you get a new result and the data continues to flow. So flowcharts, certainly right. And you will use flowcharts in the future, more so actually, especially if you go into specialized areas of programming like parallel programming and things like that. All right, so so here then we have, you know, salary. So that seems to be the thing. So it's 30,000. So if your salary is greater than 30,000 or less than 30,000, so let's say that you make, you know, 40,000, 50,000. Right. So 50,000 is 50,000. That's current value of salary. So is 50,000 greater than 30,000? True or false?
Yes.
Yes. Okay. True then. Right. That's it. That's pretty much what you have to do always. And then, okay, so now you go in this direction. And then now there's another variable called years on job. And let's say that in this case, you've been on the job for a little less than 1 year. Let's say 11 months. So that's one year, point something, 0.90 years. And so now 1 year, let's say 1 year. So is years on job equal 1 greater than or equal to 2?
Greater than.
Huh? Is that true or false?
That's false.
False, right? That's false. And so now then you go into this direction over here. And it says display, you must have been on your current job for at least 2 years to qualify. Okay? And so, you know, the program then, fortunately, you know, gives you that message. And now you finish up and you continue on to the end. And that's the sequence that you took. If it was, you know, true, then, you know, you'd go into you qualify for your loan or whatever, and so on. So that's, you know, that's the idea as the data is flowing through these flowcharts. Are there any questions about this part? All right, seems like there's no questions. Let's keep going then. This is pretty easy stuff. So here we have the classic example of nested decision structures, right? The grading, right? So you guys, you know, your nemesis, right? You know, grades. So we have a structure here, the if statement, the if, then, else, if statement, mouthful there, can make nested logic simpler to write. Okay, and so in this case, the classic example of this is you have your score on, let's say, an exam, right? So you got an exam and you got an 84. Okay, so that's your grade. You know, you do your exam online, let's say, and the program, you know, uses a Scantron. So I'm sure you guys have seen Scantrons. And so you put in your little multiple choice there, and then that Scantron gets sorted through some machine. Or you do this on a computer, right? You know, and you enter your values. When you took your SATs and things like that. And so at the end of the day, it gives you a score, and then the score is going to flow through this statement you can see here, and it's going to assign you a grade, right? So if the score, so notice the logic here. If the score is less than 60, so you're going to evaluate that Boolean expression, is 84 less than 60? No. So that's false, right? So then you don't go in this direction. So now that means you go in this direction, right? And it's going to say if score, which is 84, is 84 less than 70. No, right? So that's also false. All right, so it means it's not going to go in that direction. So it means now you, now you go in here. Else, if score less than 80, is 84 less than 80? No. False, so you don't do that one here. So you flow now into this one. And now you're going to say, if it's 84 less than 90, true. And because you only go in one direction, you execute that and you exit the program. So you will not go into this flow because you found the match that you were looking for, right? So you found your match. It's a terrible check. Okay, you found the match that you were looking for, and basically then you got a B. And as it turns out, that's what it should be, and so you got it correct. Notice this actually has a little bit of logic hidden in there because it's actually considering ranges, right? It goes from 60 to 100, 70, 80, 90. And it kind of does exclusion, right? So it's excluding things because it's just evaluating. All right, all it's saying is it's only looking at values previous. So, it looks at the number and it says, oh, are you less than 60? Next time around, it's going to say, are you less than 70? But you already ruled out this one. So really, you only end up evaluating that because you kind of already looked at it. Then it looked at that one, and it's the same idea. Okay, you already excluded this, so you're really only looking at that, and you continue doing that, so on. And so here, this one has a little bit of logic in it as well. And that these are the things, this is the logic that you're going to have to, consider. Now, most use of if statements is going to be very straightforward, but sometimes, we'll start trying little, as we look at problems. Certainly, some of the problems in your book will have a little bit more complexity. Now, keep in mind one thing that I may be doing. I'm not saying I'm doing this, but is I may be giving you problems like in the middle of the chapter. Oh, sorry, of the homework problems. I may be giving you like medium complexity problems, and I may be saving the more complex problems for the exam. So one recommendation I would do is make sure you practice all the problems in the back of the chapters, okay? So even though you might think, oh, he only gave us 5 problems out of 12 or 15, well, do all of them if you can at home. And the great thing about it is you can just write the Python code and you'll know if they work or not, right? And that's my recommendation, because remember that the exam, may have a problem that's very similar, or it may have a problem that's a little bit harder. And it might be problems like these which involve a little bit of logic. Any questions? All right, seems like there's no questions. Let's keep going. We're making good time. I think. Like I said, these topics I don't like to rush. There's like 3 topics I don't like to rush through. Ifs, you know, iterative structures, conditional structures, and arrays. Those are very important. The 3 most important topics I think for this class. So definitely, files are also an important one. All right, keep going. All right, so the case structure. So here, I know some of you have probably taken a programming class in high school before or on your own. We do have, besides the if statement, programming usually has this idea, the case. And actually, I'll give you the best example of the case. It's probably, you know, there's a classic example of why, you know, why do we need the case? You know, it's more of a convenience. It's not really that it offers anything more powerful than an if statement. Instead, it's just more presentable. You know, it's a structure that's easier to look at, and in some situations, it might be a little bit more convenient. So the case structure lets the value. So let's think about the case structure, right? The case structure. The case structure lets the value of a variable. The case structure lets the value of a variable or an expression determine which path of execution the program will take. Can be used as an alternative to nested decisions in particular. So I think, you know, that definition is not very helpful, but I'll take a look, you know, we'll take a look at an example where it's actually a little bit clearer, right? But it's like, imagine like drawers. It's like a, you know, like a cabinet. Every drawer is an option for a direction to take or a path. So we'll take a look at that. Here is the flow chart of it. Of course, we have, you know, the condition just in one place, right? And then we might have multiple paths to follow based on what it is. You know, is it this one? Is it that one? You can see the value is plugged in there, right? And those are that's how the flow chart works. And then based on that, then you say, you know, oh, okay. So for instance, if it's February, that's month number 2. So number 2 is there. So you go to February. And so the path would go like that. Okay. And so that's the flow chart, certainly. That's the flow chart of this. Okay, so it doesn't, let me see. Okay, I don't have an example of this. So let me just write the example myself because it doesn't have it in the slides. So the case, if we look at code, a case would look like this. Case, month, and then you would say something like, you know, if it's 1, then display January. If it's 2, then you would say display February. If it's 3, 3, display March, and so on. So you can see it's just a structure that allows you to have the, you know, the case, the variable in question, and then the individual values that you're comparing to. Whichever one of those matches, you know, you follow that path. Why do we have a case? The reason why we have a case is that whenever we have conditional structures that involve a lot of options. So for instance, if you saw in the previous one, we just had, you know, like 4 or 5 paths to follow, right? So that's not too bad as far as the score, you know, as far as creating a nested if statement. Here in months, you might argue, well, that's not too bad. It's just 12 months. I can do it in an if statement instead of using this case. But okay, sure, fair enough. But what about, let's say you were calculating tax nationwide, and every state could have a different tax rate. There's 50 states, right? So now you would have to have a case structure for 50 states. So one of these for every state, that's 50 of these. And so that would be 50 nested ifs. That might make just a little bit cumbersome. You know, you have to pay a little bit more attention to what you're doing. Whereas with a case, you know, it's a very, when you look at it, the structure looks pretty good, pretty clear. And so that's basically all it is. It provides no advantage over the if statement whatsoever. You can do it with both, certainly. This one just provides a little bit more visually, okay, structurally. And remember that writing code is about readability, right? Because you never know, you know, you might leave the company and someone else is going to come in to look at your code. And so you want to make it as readable as possible, okay? So this is not something that we're going to stress so much, as we're going to spend more time on the if statement, but certainly be aware that there is this type of iterative structure. Any questions? All right, seems there's no questions.
So basically, case.
Yeah, go ahead.
So basically, case is just like a simplified if. It doesn't matter which one you do.
It doesn't matter. They're both the same. The case is just, as I said, it provides a little bit more structure. So let's see if I can find some room here. So, you know, if some condition, then else if some condition, then, and then the statement here, then some statement else if, you see it's just a little bit more writing if you do it like this, right? Whereas if you just do the case, just case, you know, variable, oops. And then, you know, you have the result basically, you know, like we did this. Let's say the variable is state. Actually, let me do that. State, and then I'm going to say here, you know, Texas, right? And then that's the rate for Texas. Then you have Indiana. You have New York, and so on. Do you see that? It's a little, whereas here you'd have to like, is state equal Texas, then that is state equal New York. It's a little bit more wordy. Do you see that? Sorry, that's my phone. Do you see the difference, guys?
Yeah, and case work on Python, right? It's
Oh yeah. You can try both of these. Make sense?
Yep.
Okay, great. Yeah, so this is just an example. We will mainly focus on this one, okay? We'll mainly focus on that one and not so much on this one. All right. All right, so let's keep going. So case structure, we talked about it. All right, so now let's look at logical operators. So a little bit more into so let's call this like more complex Boolean logic, right? So this is more complex Boolean logic. All right, so we have logical operators. So logical operators are used between conditions to create complex Boolean expressions. Okay, so logical operators are used between conditions to create more complex Boolean expressions. So it's something like, you know, if x greater than 32, and then you have y equal 1022. So you have those two conditions, and you want to actually now use them together, right? So you could say, well, if x greater than 32 and y equal 1022. Or you want to say x greater than 32 or y equal 1022, and so on. Or you want to use not, which basically says, I want to do, and it's a convenience, I want to perform this when you have x greater than 32, but the opposite of it. So I'm going to do not it. So not this. So it's like saying, it's like you can do this when we're talking. You can say, I want to go to the concert, and then you just put not in front. I want to not go to the concert. You made the opposite of what the condition was, and that's the same certainly here. That's sometimes very convenient to reverse the Boolean expression. So if I look at an if statement and I have an expression that evaluates to false, whatever it was, it evaluated to false. Well, now I put a not in front of it, and now this condition actually evaluates to true. Okay, just by doing that, because you're just reversing it. You're doing the opposite. So with the and operator, both conditions must be true for it to be true. With the or, either condition must be true. So just one of them needs to be true. So that's like saying I have if condition and condition. All right. So if for this to be true, so what this is saying is for this to evaluate to true, you have if true and true. If both conditions, then this is true. In the or, this is, you can see it there. In the or, if true or true. All right, it says either condition must be true. Okay, so sorry. False, then it doesn't matter as long as one of them, because you're going to say if it's raining or I have an umbrella, I will go out, right? So you're going to go outside if it's not raining, or you have an umbrella. Whereas the previous one is if is not raining and or no, let's say if it's snowing and I have boots. If both things are true, then true. But if it's snowing and I have boots false, then you don't go out. All right, and then the not, as I said, just reverses the truth of an expression. Or another way of saying it is it reverses whatever the final expression is, you not it, and now you get the opposite. As I said, we'll do more examples later of this. I'm just introducing the topics. We're almost done. I think we have like 2 slides left. All right, so here's some nice examples of logical operators. Okay, so we have some examples here of the and, or, and not, some more concrete examples. So if temperature less than 20, that's pretty cold, and minutes greater than 12, then, polar vortex, right? So, you got a polar vortex there. Display the temperature is in the danger zone. Polar vortex, as we get some of those in this area. So if temperature less than 20 and minutes, this probably means minutes outside, greater than 12, then, polar vortex. Or the or example here, if temperature less than 20, still pretty cold, or temperature greater than 100. So we are actually now creating a range. So the best way of thinking about this is to kind of visualize it. So I would say temperature here is 0. This is 20 degrees. This is Fahrenheit, obviously. And then over here, this would be like 100. So basically what we're saying is either that range or that range. So if you fall in less than 20 or temperature greater than 100, again, it's not a polar vortex anymore, but the temperature is, you know, it's either pretty cold or pretty hot, not within like comfort levels. Okay? And so in that case, you know, either that one or the other one is true. As long, you know, obviously they're like mutually exclusive, so it can be only one or the other. And then the final one is the not. See that there? So not. If not temperature greater than 100. So notice here the temperature is 120 degrees. Wow, that's maybe not 105. If the temperature is 105, sometimes I do this, you know, that you might want to try that sometimes, or keep track of the variable. You might just write the variable. Five, right? So if the temperature greater than 5, if temperature, which is 105, is greater than 100, that's true. So this is true. This evaluates to true. Then display this is below the maximum temperature. Well, this is correct when you not it, because now the whole thing becomes false. Right? So you just think of it as the opposite of it. So if it's not that, and so I should say actually that this is true really, because it's really the Boolean condition that you're thinking about. You're just saying temperature 105, if not temperature greater than 100. So in this case, if the temperature was 68, so this might be better to visualize this. So 68, is 68 greater than 100?
No.
No, so it's false, right? But for it to execute here, this has to be true. So if we do not false, what is that? True, right? And so the entire expression here just became true. And now we go in here and then display this is below the maximum temperature. Is that correct? Yes, right? Because 68 is below the maximum temperature. Does that make sense? So this one works better in the second example that I gave versus when I was using 105. When I was giving 105, it would not have gone in that direction because it would have been false. Make sense, guys?
Yep.
Excellent, excellent. All right, let's keep going. I think this is the last slide, or do we have one more? No, we have one more. Okay, so let's look at this one. This is range checking. And range checking, I've already talked about it. You know, it's kind of like checking the temperatures or the grades, right? So the best way that I like to think about this is, you know, kind of create a little range like this one here. But it's still talking about logic, okay? So often used for range checking when checking for a number inside a range. Use and. So for instance, and as I said, with a lot of these, it's best just to look at just to look at, try to work it out really. So if x, and we need to define a value for x. So let's just think of, so here we want a value within a range. So we want, let's say, just right in the middle, 30. Okay, so with that example, I can work this out. So I'm saying there's 20 and then there's 40. So if x greater than or equal to 20, so including 20, I'm saying, is the number greater than or equal to 20? Yes. So this evaluates to true. And if x is less than or equal to 40, yes. So the range is this one. My 30 actually falls within that range. This one also evaluates to true. And so remember now that true and true evaluates to true, which means you will go in that path. Okay, so the value is in the acceptable range. Okay, now the opposite of that is checking. When checking for a number outside our range, you can use or, right? So these are not, I wouldn't recommend memorizing any of these. Instead, understand how they're used, and always, kind of, do what I'm doing, try to figure it out. Because a lot of programming sometimes is this. You're never gonna know. Oh, well, some people might be, really good at this, and they may just be able to write the if however it is. What I like to do, and some people do, is I just write it. Okay, I'm going to write the if statement like this, and then I'm going to test it. Okay, what do I get? And then I'm going to see, oh, I'm actually getting, I wrote this the opposite way. So then, and I start to tweak it by trying it out with different numbers until I figure out, what, and I'm happy with what I'm getting, right? So definitely it's not, these rules are not about memorizing, but instead about like working it out and, figuring it out. So when checking for a number outside of a range, use or, all right? So we know that. So again, let's do x equal 10, okay? That we know it's gonna be between 20 and 40. So now it says if x less than 20, yes, it's 10. So then this is true. Or x greater than 40. So let's say x was 50 maybe. So again, it would fall there. So either one will be outside of the range that has been designated from 20 to 40. So either one. So this in the first situation, in this one, we get this true and false, but we know we only need one of them to make the entire expression true. And so if we make the entire expression true, then we know true allows us to go in that flow. So display the value is outside the acceptable range. Okay? Any questions about this? All right, it seems like there's no questions. So let's look at this other example, Boolean variables. A variable of the Boolean data type can hold one or two values, true or false, right? So that's the definition. Is there are variables can be, in most, this is a generic statement for most programming languages, right? They can be int, they can be float, which is like, so int is just like a 7, whereas float is 7.3, right? They can be strings, like hello, right? And they can be Boolean. So usually these are the main types. And then from here, there are families, you might have in C, you might have like int 32, in 64. That just means you can store bigger numbers. But really, right now, all we care about is that we have another, we're defining another Boolean type. And this is just equivalently in a computer, this would just be a 0 or a 1. Right? That's what's so great about defining a variable as Boolean is really, think about it, you're only using, maybe as little as just 1 bit. Because if the bit is 0, then it's false. If the bit is 1, then it's true. Right? And that's basically what Boolean does, is Boolean stores either true or false. Right? So at the level, at the computer level, it might be something very simple like this. The interpreter or the editor that you're using for programming will translate that into the keywords. Of course, when you are writing programs, do not use variables named with the words true or false, because those are obviously reserved keywords. So a variable of the Boolean data type can hold 1 or 2 values, either true or false. Okay. So for instance, here we have the pseudocode declare Boolean is lunchtime. Right? So if it's lunchtime, if time greater than or equal to 12, all right, then this becomes this eval. So right now it is actually 1:22, right? So currently time is equal to 1:22. So if time greater than or equal to 12, yes, it's greater. So this evaluates to true. That evaluates to true. Therefore, we go in this path. And now notice there is a variable called is lunchtime, which is this one. Lunchtime. And so we assign to it the word true. We assign the Boolean value there. Okay? Else, if it was earlier, we would have gone in that direction and we would have assigned to it false. And that's basically all it is. This is just showing you how to assign the value to the variable when you define a variable to be of Boolean type. Okay. All right. Any questions about this example? All right. So
Basically, Boolean is still just true or false.
Boolean is the data type. When you use Boolean for a variable, you're basically, that variable can only store either this or that, nothing else. Make sense?
Yeah.
All right, good. Remember, guys, we're talking about pseudocode here. So when we're talking about syntax, this could be a 0 and a 1. This could be the word true or false, lowercase. I mean, it can be a lot of T and F. I mean, there's no reason why it can't be. But those are just syntax related things. But the idea is to understand the logic of a Boolean. Okay. All right. So these are the slides that are just generic pseudocode flowcharting slides. Let's now move to the other set of slides, which are the more Python related. Okay, and as you know, these slides do repeat a lot from the previous one, so I'm not going to repeat everything. I'm only going to point out little things that might have to do with Python itself. Okay, but as you can see here, we're going over decision structures and Boolean logic again. Okay, so I'm just going through this. All right, so let's go over here. So we're talking, as you know, about these statements. This is more now Python specific. So we talked about control structures, decision structure. And this is really where we're, the if statement, specific actions performed only if a condition exists, sometimes called selection structure. I like to call it conditional structure. That's, better. Decision structure is fine too. So we talked about this, it's the diamond. Talk about that. You can see that there. It's pretty much the same example from the previous slides. The Python syntax now, this is important. Notice that before, as I said, we were doing if, condition, then statement, 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 and if. Notice here now, instead of then, in a way, what you have is a colon. That's Python uses colons for structures like these, conditional structures and iterative structures and functions. We will see that. It'll become intuitive later. The condition pretty much the same, keyword the same. And as I said, notice here, the next statement would be aligned with the if, right? And so that means that's the end of the structure. But this indentation provides the indication of beginning and end, okay, in Python. The first line, known as the if clause, includes the keyword if followed by the condition. The condition can be true or false. When the if statement executes, the condition is tested, and if it is true, the block statements are executed. Otherwise, the block statements are skipped. Right? You can see that there in this example. All right, we talked about Boolean expressions, so I'm not really going to repeat that. So we've talked about these, talked about those. Those are pretty much the same. You can see in Python, actually, you do use the two equals, and the not is exclamation and the equal sign. Okay. Don't confuse it with the assignment statement. We talked about this, right? So we've already covered that. Okay. Covered that. You can see here the example of if balance equals 0 versus if payment not equal to balance. Now we'll learn about nested blocks when we look at more examples, but that is also obviously possible here. All right, so here is the if-else with the else condition in Python. Notice if condition colon else colon indentation, and that's it. That's the Python if statement structure. Okay. And notice this is very important. Statement must be consistently indented. Okay. So that's I would say that's usually like the hardest thing to figure out about or get used to about Python. But you'll get used to it really quickly, really. We talked about this, right? So we've already talked about the flow chart. You can see here the, kind of more detailed description of how to do it in Python. So if condition is true, then this block of statement is executed. Else, we execute this one. Okay, and then, that's kind of the same thing. If the condition is false, we jump over here. The end is always after the if statement. So what this is saying is, if this is true, then the code doesn't execute. It executes this, else it just jumps outside, and it doesn't execute what's in the else, because it can only execute one or the other. We talked about that. This is just comparing strings. Okay, and just, as we know, the strings are ASCII characters. Okay. So we'll see this with it's better to understand this with examples, so don't worry about this. We talked about nested structures. We talked about this, the flow chart already, right? We talked about it. So one important thing, it's important to use proper indentation in a nested decision structure. Important for the Python interpreter and for your sanity, right? Because otherwise, as I said, it's very hard to debug those types of errors. You want to make your code as readable as possible. Make sure the else clause aligns with the if clause, okay? So if you do if, the else should align. That's why, get into the habit, maybe just 4 spaces, right? So that way you always know, you can always go 1, 2, 3, 4, and make sure they're aligned. And these statements actually, this is very important actually. The statements within the if statement should also be aligned, right? So I should say that if it wasn't obvious, that they should definitely be aligned as well. All right. The if, elif, else, notice here that Python has this little trick, right? So instead of doing like in the pseudocode, if, and then else, and then if, and then, writing all of that, and then finally an else at the very end, they combine the else if into one word called the elif. Okay, so just be aware of that. And that way you can have multiple elifs in there. So it makes logic of nested decision structure simpler to write. Okay, because it's 4 letters. So it's less wordy. It just looks better. A lot of the time, that's what you want in programming. When you have a lot of code, you want to make sure that your code looks clean and structured and organized. It's aesthetically nice, and it also it's easier to read, and it just makes it better overall. Okay. Again, the same thing. Align these words. Make sure the if, elif, and else are aligned. Okay. But we talked about this one. We talked about the grading. If we didn't see the flow chart before, here it is. You can see an example of how to write the flow chart. Notice that, how you're evaluating this. Logical operators, right? And, or, and not. So here you can see the reserved words in Python. Notice they are lowercase. Just like we discussed before, but just right now, as you know, all I'm pointing out is the little syntax. The definitions are still the same. And that's what, as I said, that's what's so great, is that regardless of programming language, everything that we discuss, pseudocode and flowcharting, is still consistent, just a little bit different. Here's a little truth table. Truth tables are pretty nice. You can have them in your cheat sheet. I do recommend, as you start programming, start creating a cheat sheet. Try to fit things that are important into just one page, all right? Don't have like a whole book, have one page, fit everything that you can in there. And, one thing you might want to have in there in the beginning is truth tables, the operators, that way you can always look them up in your cheat sheet really quickly. And, eventually you won't need the cheat sheet, but initially it's not a bad idea. So we talked about this already. So we have and. Both need to be true. So only this one, right? So only that one evaluates the true. This is true. These other ones are false because they only have, you need to have both truths. Here's the truth table for the or. Again, go ahead and copy it or write it down in your cheat sheet. As you can see, here it's true as long as you have one. So here you have two, here you have one. So these are true, 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 and this one is false. And that's the truth table. All right, so the not operator, just, as we discussed, this one's pretty intuitive. It just gets you the opposite of what you have in that condition. Talked about it. Checking numeric ranges, we've already talked about this one. We talked about, the Boolean data type in Python, although you don't really have to define it, right? In Python, it's still, you can think of it. We use the reserved words true and false. So this is really what you're going to write there, true, false, in the assignment. And that's pretty much it. As you can see, pretty easy. For this topic, we've covered pretty much if statements right now, and we will. So that's as I've said before, the approach that we're going to take is this one basically. So in the lecture, I will go over the slides, which are pretty much summarizing the book. So if you want to read the book, certainly go ahead and start reading it. I think it was chapter 3. Just look for conditional structures. You can also read the Python book if you have it, although it's not required. And then, just read these topics. Maybe already start practicing how to write pseudocode, how to write flowcharts, how to write the Python code. And then on Thursday, this Thursday, I'm gonna do some exercises from this chapter. We're gonna do those, pseudocode, flowchart, a little bit of Python in the class, and then I'll just leave it open for any questions that you might have, either about the homework that's due that night or the next homework. So this week, I'm going to assign chapter 3 problems. They're actually already posted on Blackboard. I just haven't written down which ones you have to do. So if you'd like, you can start doing all of them. You should be doing as many as possible anyway for the exam. And then maybe some of those you'll already have done for the homework. And then that homework will be due a week from Thursday. So that will be the new homework assignment. And then that's it. So that's pretty much it for today. This is a good stopping point. So I'll stay a couple of minutes if there are any questions about anything. All right. Otherwise, we can stop here, and I will see you guys again on Thursday. Okay? I
have a question.
Yeah, go ahead.
So on turning in this week's homework on Thursday, so you want us to put it? So I've been using my coding, but I've been putting in a Jupyter notebook.
Okay.
And then I save that into a file. So do you want me to save? Do you want to put like a screenshot of the code running
in the Jupyter notebook, you mean?
Yeah, in the Jupyter notebook.
You can put a screenshot of it, and that's perfectly fine. The one thing I definitely do need is the lab report. And if you're creative with your lab report in a sense that you put the screenshot of the Jupyter notebook in there, I'll understand what you did. You know what I mean? It's not like I have to run this. The things we're doing are so simple that I don't need to run things right now. So it's perfectly fine if you want to. Remember though, if you're going to be submitting multiple files, zip them, right? Zip them and load the zip file. Otherwise, the report should be fine. Yes.
Okay.
All right, guys. So like I said, if you have any questions, go ahead and ask. Otherwise, we'll stop here for today, and I will see you guys Thursday.